An entry here from Miles. Nuclear energy. Okay, that is the correct answer. Very good. So we have nuclear energy for 3 across. Next, what about this? 5. This is 5 across. 2, 4, 6, 8, 10, 11. Solar cells can collect the sun's energy and convert it directly into electrical energy. So what is this? All right, very good. This is solar energy. Okay, next, number 6. High energy from falling water. What is this? For a while, let me accept. Summoning late. Number 6, energy. Okay, very good. Correct. Miles. Hydroelectric. 2, 4, 6, 8, 10, 11, 12 boxes. So hydroelectric. Okay, next. Number 7. Coals, natural gas, and oil can be burned in power plants to produce steam. What is this? 7, 2, 4, 6, 8, 10, 11. 11 letters. Okay, very good. That's correct, Pauline and Miles. Fossil fuel. Okay, correct. Next, number 8. Circular devices made up of many blades. What is this? Circular devices made up of many blades. All right, very good. From Ira, Sophia, Pauline, Rupert, Kate, and Marinelle, turbine. Okay, next, coalescence of two colliding nuclei of certain elements. Two nuclei combined together. What do you call that? Diba, if you split the nucleus, that is nuclear fission. What if you are going to combine? Okay, very good, Sophia. That's correct. Nuclear fusion for 9 across. Okay, we're done with across. Let's proceed to down. Okay, this is 1 down for a while. Ay, nako. Lawrence. Okay, number 1, converts mechanical into electrical energy. This is 1 down. 2, 4, 6, 8, 9. All right, very good. Sophia, Ira, Kate, Pauline, and Isa. Generator. Next, used to turn a turbine. This is 2. Okay, very good. Marinelle and Kate, that Isa, that is team. Next, splitting of the nucleus of an atom. 3. This is 3. Splitting of the nucleus of an atom. 2, 4, 6, 8, 10, 12, 14. 14 boxes. Splitting of the nucleus of an atom. All right, very good. That is nuclear fission. Correct. Six, okay. Next, 4. Underground water heated by a molten rock can turn into steam, which can be obtained through steam vents. This is 4, 2, 4, 6, 8, 10. 10 boxes. Number 4. What is this? Underground water heated by a molten rock can turn into steam, which can be obtained through steam vents. Okay, we have answer from Sophia, Ira, Aliana, and Isa. That is correct. Geothermal. Okay, very good. So I hope that you got all the words. So this is just a review from yesterday and in our previous discussions. Okay, let's proceed. Thank you so much for your participation. Let's have the transmission of electricity. When you say transmission, what comes to your mind? What would be the synonymous term of transmission?
Transfer.
Okay, transfer. Very good. So after the generation of electricity in power plants, we need to transfer this electricity. Okay. So during transmission, some of the energy is lost due to the resistance of the electric wires. So this results in the production of heat. Okay, so when we say electrical resistance, this is a force that will counteract the flow of the current. Okay, so that is why we need voltage. We need to increase the voltage so that it can push the electric charges. So whenever electricity is transmitted, power loss also occurs because of the electrical resistance. So the companies uses step up transformer, okay, to raise the voltage and to reduce the current at the same time. Okay, so we have what we called as the step up transformer. So it will increase the voltage of the current. Okay, so it will be transmitted to what we called as pylons. So these are pylons, or also known as the transmission lines. Okay, so high voltage electricity is fed into the national grid system through which it is transmitted efficiently over long distances to substation. So when we say national grid, this is a network of power transmission lines that connect all power stations across the country. So it helps ensure the continuous supply of electricity to end users, even if one power station breaks down. Okay? So, ang control ana is the national grid system. Okay? So that is for transmission of electricity. So para ang electricity makatravel in a longer distance, it has to be increased in terms of its voltage. So they use the step up transformer. Okay? Para makaabot siya sa iyang destination. Okay, for example, if the power plant will produce 2,200 volts, okay, so the step up transformer can further increase the voltage up to 220,000. So imagine sa kadako ang iyang pag-raise from 2,200 to 220,000 volts for a while. But it seems like we're advanced regarding those. Care more those one. Okay, for a while, nasa ko i-accept. Jade. Okay, so we have what we called as the step-up transformer and then the step-down transformer. Okay, for step-up transformer, it increased the output voltage. And then input voltage is low while the output voltage is high. Okay? And then for step-down, it will decrease the output voltage. But of course, iyahang input voltage is high. Then it will be reduced to smaller voltage sa iyang output. Okay? So there are again, two types of transformer, step up and step down. Step up transformer will increase the voltage output. And then for step down transformer, it will decrease or reduce the voltage output. Okay, let's proceed. Okay, let's watch this supplementary video for transmission lines for a while.
Transmission lines work. How do transmission lines work? 10,000 kilometers. This is, for example, the distance between Rio de Janeiro and Berlin, or the length of 50 Hertz's extra high voltage grid that transports electricity with 220 or 380 kilovolt over large distances. Our transmission system connects the renewable and conventional sources with the regional and local distribution systems. From the distribution systems, the electricity is then delivered to the households. Over land, the electricity is almost exclusively transmitted using high voltage overhead lines and only in special cases via underground cables. One important element of overhead lines are the pylons. They carry the conductors. The 50 Hz grid contains about 14,000 pylons. In particular, two-level pylons where the conductors are arranged in a triangle, thus forming a system, or in other words, an electric circuit. Conductors have to be isolated from the earth pylon. They are therefore fixed with isolators. Normally, the difference between 220 and 380 kilovolt lines can be pinpointed by checking the number of isolators. 220 kilovolt lines frequently have 2, 380 kilovolt lines 3 or 4 isolators. The electricity is transported through conductors in form of small electrons with a negative charge. The live conductors are made of aluminum steel, a conductive material. Earth wires are attached to the top of the pylons. They do not transport electricity but protect the live conductors against lightning strikes. The overhead lines of the 50 Hz high voltage grid are usually equipped with two electrical circuits. Electricity flows on the left and the right side. If one system or even the entire line fails, the rest of the power grid ensures the secure and uninterrupted electricity supply. This securing principle is called N-1. When 50 Hz decides to build new lines, we respect certain rules. We avoid residential areas wherever possible, bundle the lines with other infrastructures such as streets or railways, and try to affect natural areas as little as possible. We compensate any environmental impact. Protecting human beings, wildlife, and nature is our highest priority.
Okay, so that's how the transmission lines work. So any question for transmission line before we'll proceed to distribution? Short track pod ni ang distribution. Okay, so let's continue with distribution of electricity. Okay, so let us answer first the process questions just to see if you have learned something. Let's answer number 1. How is electricity transmitted to the consumers? Please type your answer in our public chat box. How is electricity transmitted to consumers? Okay, through transmission lines, power grids. Okay, that will be considered. Power grids, transmission lines. Okay, next. Differentiate this step up and step down transformer. What about this? What's the difference between a step up and step down transformer? From power plants and power grids, step-up transformer increases the voltage output. Okay, what about for uh, step down? Okay, step down transformer reduces or decreases the voltage output. Okay, that is correct. Let's proceed. Okay, so this will be the flow chart. So let's go back to the flow chart of the electricity generation, distribution, and then electricity generation, transmission, and distribution. So we're done with the power plant, how electricity is generated. And then it will be transferred to a step-up transformer to increase the voltage. And then transmission lines. And then we have another transformer. So this is the step-down transformer to reduce the voltage. And then before distributing to the distribution lines. Okay, local distribution lines. So let's talk about distribution, uh, electricity distribution. Pinata mag-exit card. Have this. Okay. So what happens next after electricity is generated at a power plant and then transmitted through high voltage power lines? After high voltage power lines, which is the transmission lines, it will be transferred to the substation. Okay, step down substation. And then distributed again to the local power distribution lines. Kanisha, this is an example, smaller version of transmission lines, ang local power distribution lines. Okay, mao ni sila. And then before tayo siya i-transfer, it will be further reduced ang iyang voltage to the end user or consumers. Okay, so let us explain the distribution of electricity. So after electricity is generated at a power plant and transmitted through high voltage power lines, it is then distributed to household and industries through local power distribution grids. So this is the picture, sample picture of a local power distribution grids or lines. So at a substation, a step-down transformer reduces the voltage to its original value. 'Di ba after sa iya pag-generate sa power plant, the voltage is originally 2,200. Tapos gi-raise din siya to 220,000. So this time, pag-abot sa step-down substation, ibalik na po siya sa 2,200 voltage or volts. And then the voltage is further reduced pa gyud to the local power distribution lines kani mga inani. 'Di ba naman ni sa inyo ang gawas or sa inyong barangay, visible man ni sila. So from 2,200 volts, it will then be reduced to 220 volts or 110 volts by the step-down transformer. Mo ni siya ang step-down transformer. Okay, so the electricity then passes through your meter into your homes and wires. So again, why we need to reduce the voltage upon entering our meter? Why? Why we need to reduce the voltage before siya mo enter sa atong households?
Nature, most of our appliances are na 220 volts.
Okay, most of our appliances kay na ay certain okay, voltage, 'di ba? Limit na voltage. So if masobraan, then it will explode. Okay, so for safety purposes, we need to lower the voltage. Okay, that's the reason. So let's have our review. What are the three stages in providing electricity to consumers? So kana lang siya for the distribution of electricity. So what are the three stages in providing electricity to consumers? Please mention again. What are those stages? Please type it in our public chat box. Okay, generation, transmission, and distribution. Okay, that is correct. Okay, this time, let's watch two videos about distribution, electricity distribution, and then electrical safety, okay, and conservation of electricity for a while. By the way, for your IPT, deadline ha, April 11. Kay, napong ko ganina. So let us stick to the original deadline, April 11. You have, pila na lang ka weeks? 2 weeks na lang din. Sige lang, mauman naman na ninyo.
Excuse me, Chair.
Yes, Ian?
Chair, sa PT, Chair, ba kay pila ka minutes ang video, Chair?
3 minutes to 8 minutes.
Ay, okay, Chair. Thank you, Chair.
Okay. Ang Holy Week is, kuan pa man, ang walay class, April 14, 15. And then deadline man nato is April 11. Okay. Sige, let's watch this video. Summary na din ni siya, how it works, generation, transmission, and distribution.
When plugging in your cell phone before you go to bed, have you ever wondered, where does all this power that I depend on even come from? And how does it get to me? Good questions. And the answers can be broken up into 3 steps: generation, transmission, and distribution. Electricity is generated throughout the province at hydroelectric, nuclear, and gas power plants, as well as through renewable energy such as wind and solar, much of which are owned and operated by Ontario Power Generation. Once the electricity is generated, it must be transmitted to urban and rural areas in need of power. 30,000 kilometers of high voltage transmission lines connect the generating plants to transmission stations. Think of it as a highway for electricity stretching out over the entire province. Integris is responsible for distribution, that last leg of the journey. Distribution involves taking the power generated from over 260 provincial transmission stations, feeding the Integris substations located throughout your community, and then to your homes and businesses. These substations reduce the voltage of electricity to a level that can be safely carried on distribution lines above and below city streets. Along these lines are transformers that lower the voltage one final time so the electricity can be used by homes and businesses. In total, Integris' distribution system contains almost 1,000 kilometers of overhead and underground wires and cabling connecting customers to their substations. So there you have it, from generation to notification. A lot goes into making sure your cell phone is as recharged as you are when you start your day.
Okay, this time, let's proceed to dangers of electricity and safety measures.
Spiky and Bubbles are flying a kite. They're having fun, but it's a dangerous setting. Spiky is flying the kite too close to the power lines. If the kite gets stuck in the power lines, he could get an electric shock. How? Well, the metallic wire of the kite is a conductor, and so is our body. If the kite touches the power line, a large electric current may flow down the wire, moving through the person and into the ground. This completes the circuit and causes an electric shock. That is why, when a large current passes through a person, he or she can receive an electric shock. If the current is very strong, it can prove to be fatal. An electric shock occurs when a person touches live or damaged wires, causing current to flow through his or her body. Besides electric shocks, unsafe use of electricity can also cause short circuiting. A short circuit occurs when wires accidentally touch, forming a path of very low resistance. This draws a large current from the source and overheats the wires. This overheating of the conducting wires can also result in a fire.
But even with all these dangers, we need electricity in our daily lives. What can we do?
Spiky does have a point. To solve this problem, we can use the following devices to ensure the safe use of electricity. Fuses, miniature circuit breakers or MCBs, earth wires, 3-pin plugs, earth leakage circuit breakers or ELCBs. Let's take a closer look at these devices. A fuse is a piece of thin conducting wire with a low melting point connected to the circuit. When the current in the circuit exceeds a safe limit, the fuse heats up and melts, breaking the circuit and stopping the flow of current. Fuses protect against short circuits and overloading. But replacing a fuse again and again can be quite tiresome. To overcome this problem, automatic fuses called miniature circuit breakers or MCBs are used. Whenever there is an excess amount of current flow in the circuit, the MCB automatically trips off, thus breaking the circuit. The MCB can then be turned back on like a switch without the need to replace the automatic fuse. Next are earth wires. Earth wires protect us from electric shocks by sending excess current into the ground. If short-circuiting occurs in a device, current will flow directly into the earth through the earth wire. This protects the person who touches the faulty wire. Let's discuss the 3-pin plug now. 2 pins of the plug connect the appliance to the main supply, while the 3rd pin connects the appliance to the earth wire. The earth wire has a similar function. It sends excess current into the ground, thus preventing electric shocks. Lastly, we have the earth leakage circuit breaker. An ELCB is a safety device used in electrical appliances to prevent electric shocks. It detects a small current passing through the earth wire of appliances. It then turns off the power when the amount of current reaches a dangerous level. There are several ways to prevent electric shocks and short-circuiting. Here are some of the safety measures we can take. 1. Don't poke anything into electric sockets. 2. Don't touch electrical appliances or sockets when your hands are wet. Water can conduct electricity. 3. Don't use appliances with damaged or exposed wires. 4. Don't overload a power socket by plugging too many appliances into it. This will draw a large current which may burn the wire and cause fires. Be particularly careful about this since many of us like to connect multiple appliances to one socket. 5. Don't change a bulb until you have turned off its switch. 6. Don't try to repair an electrical appliance by yourself. Get an electrician to do it. After learning about the safety measures for using electricity, Spiky and Bubbles are now flying the kite in an open ground, nowhere near the power cables. Let's summarize. The unsafe use of electricity can result in electric shocks and short circuits. Devices such as fuses, miniature circuit breakers, earth wires, 3-pin plugs, and earth leakage circuit breakers ensure that we can use electricity safely. We can also take some safety measures to avoid electric shocks.
Okay, so that's all for our session this afternoon. Do you have any question? Sure. No, we're not. This off topic pero mag-charge ka overnight ano yun siya magtiga. Dili na. Misconception man ng kuan pag full charge na siya, dili naman na siya mag-take up og electrical energy. Mag-stop na siya, Lawrence. Okay na? Happy na? Yes, Ian. Piti ni.
Sir, pwede mabalik sa kwan, sir, kanang slide number 40.
Okay. Number 40. This one?
Oh, kana. Ah, okay na, sir. Thank you, sir.
Okay. You only have 10 minutes. So, you can do unsa man inyong buhaton mga PTs, assignment. So, continue na. And by the way, tomorrow, next meeting, we'll have quiz before you proceed or continue with your IPT. Okay, 10 items, 10 to 15 items. Okay, so please study chapter 20. LT Thursday, Lawrence. So tomorrow, quiz, and then IPT. And then on Thursday, you'll have LT2 about chapter 20. Okay? Sige. I'll exit later, 1:15. 1:20 man to mag-end, no? Dasa pa day sa oras. Sige lang. If you have questions, feel free to ask. By the way, naka-start na mo sa IPT. Isa na nag-make dire og diorama, construction. 9H. Wala? Uy. So, chill lang. Kasi na naka-start. Okay, back to me. Wala pa mo nag-start di ay? Uy. Muna na din na. Pag-start na magsugod. Kay April 11 ra ba ang deadline? Sin ma-stress sad mo. Mental health. Uy, not necessary na bago yung materials sa pwede ragin mo kuan, recycle. Sana all, Lawrence. Okay. Sige lang. Sa isa lang, dili na to idungan tanan. Yes, Lawrence.